Now we will be talking about binomial distribution, which is a type of discrete probability distributions. Why it's discrete? Because the random variable that this binomial distribution takes is at discrete values. Okay, so what is the binomial distribution? The binomial distribution, which is a really important distribution, describes the processes whose trials have only two possible outcomes. This is important. It just deals with two possible outcomes, only two possible outcomes. Example. A quality control system in a manufacturing plant labels each tested item as either, look, two possible outcomes, defective or acceptable. So the plant labels, they're going to be, or the items, they're going to be either defective or acceptable. We have only two possible outcomes if you pick one of them. A firm bidding for a contract either will or will not get the contract. If a firm do a bidding, we have only two outcomes. We don't have any third outcome. They're going to get the contract or they will not get the contract. A marketing research firm may receive responses to a questionnaire in the form of yes, I will buy, or no, I will not buy. Only two outcomes. Only two outcomes. And discrete, look, they are discrete values because they are a number of counts. We were talking about counts. The personnel manager in an organization is faced with two possible outcomes each time he offers a job. The applicant technically either accepts or rejects the offer. Accepts or rejects for each applicant, right? So all of these are examples of a binomial distribution. But there are kind of characteristics we need to, every time we work on that, we have to check them. Kind of a checklist. When we read a problem, we have to look at the checklist and make sure that the checklist works. I mean, we meet these specifications. The distribution that gives the probability of X successes in N trials and X successes in a process that means the following conditions. This is the characteristic. The trial has only two possible outcomes, a success or a failure. Buy, not to buy. Accept, not to accept. Defective, not defective. Only two possible outcomes. There's a fixed number N of identical trials. We're going to speak about this. It's fixed. It's N. We call it N. The trials of the experiment are independent of each other. They do not impact. One of them doesn't have any impact on the probability of the other one. So if one outcome is a success, this doesn't influence the chance of the other outcome being a success. Correct. The process must be consistent in generating successes and failures. The probability P is associated with the success, and it's constant. It's always constant. The P is constant and doesn't change from trial to trial. It's always P. And the failure is going to be 1 minus P. 1 minus P. In some books, they call it Q, which is the probability of the failure. Let's have an example. Lake City Automotive performs 300 automobile transmission repairs every week. Transmission repair work is not an exact science, and a percentage of the work done must be reworked. Lake City shop managers have determined that even when the machine or mechanics performs the work in a proper manner, 10% of the time the car will have to be worked on again to fix the problem. So you have a chance that 10% of the time the vehicle must be reworked again. To determine whether the Lake City mechanics are continuing to function or machines, I don't know. At the standard level of performance, the shop supervisor randomly selected 4 cars from the week's list of repaired vehicles and tracked these to see whether they need to be reworked or no. Does the binomial distribution apply to the situation or no? So we have to check these conditions, the checklist. First of all, does the trial have only 2 outcomes, a success or a failure? Yes, because when car is repaired, the car either needs a rework or no. So you have 2 options only. We have 2 outcomes. Need to be reworked or no. So you have yes, success or failure. Do the rework, do not do the rework. Is there a fixed number of identical trials? Yes, we selected 4 randomly cars. So yes. We did not do this for 1 or 2. We have not just 1 or 2. We do have a fixed number of identical trials, which is 4 randomly picked cars, right? Are the trials of the experiment independent of each other? This means that if one outcome is a success, this does not influence the chance of another outcome being a success? Yes. They are independent because you are picking randomly vehicles out of 300, right? Or out of more, I don't know. So It doesn't. I mean, if you picked one randomly and it says it needs a the rework, the next one doesn't mean that it's. I mean, they don't depend on each other, right? And the question is, if one outcome is a success, that yes, we answer this question now. And is the process consistent in generating successes and failures? That is, the probability P associated with success remains constant from trial to trial? Yes, they said 10%. There's a chance. Yes, because they said the probability of the rework is 10%, and this is constant from car to car. So P is 10%, and it's constant. When they pick a car, there's 10% chance that the car will be reworked, right? If P represents the probability of success, which is in this case, the P in this case represent that the car needs to be repaired or reworked. 1 minus P is the probability of the failure. What is it? It's 1 minus, so Q is 1 minus P, which is 1 minus 90%, 1%, which is 90%. So the probability that the vehicle will not be reworked is 90%, which is constant, and this is constant. This is constant. And one point that maybe I would like to say here, that if the sample size is at most 5% of the population size, then the binomial distribution can be applied. And actually, sometimes we don't know the condition of the independency. It's not clear, basically. So that's why it's a good rule that what you have to do is just check the sample. The sample will be sampled 4 out of 300. 4 out of 300. What do you get? You're going to get a number, right? This number basically is going to be what? It's going to be less than, actually less than 5%. 5% is the rule of thumb that we use. If you divide the sample by the population size and you got a number less than 5%, less than strictly, then that means we can actually assume that the experiment and the trials are independent, because the sample is small relative to the size of the population. So this is an important rule of thumb, can be used to determine the independency as well, basically. Just you divide them and you get number. If the number less than 5%, then you are good to use binomial distribution. Now, the binomial distribution, how to find the probability of something is going to occur. We use this formula. But actually, I will not use it. I will use Excel in this. So in the next video, I'm going to show you how to use Excel solving these examples. So binomial distribution, but let's understand these pieces. So n is the random sample size, small n. X number of successes. So if you care about x equals, for example, in this example that we give, n is 4. We picked 4 vehicles, and suppose that we are looking for the x equals 0. So the number of vehicles to be reworked is 0. Maybe 0, 1, 2, 3, 4. Right? Because if you pick a vehicle, the vehicle, what is the random variable that this vehicle takes? Either 0, that means, we're talking about the random variable is the car need to be reworked. Could be 0, could be 1, could be 2, could be 3, could be 4. 0 cars will be reworked, 1 car will be reworked, 2, 3, 4, and each one has a probability. How to find this? Using binomial distribution. How to find the probability? Why? Because we have only 2 outcomes, rework, not to rework. And the conditions are met. That's why we can use the binomial distribution. Number of successes here, and number of failures, it's n minus x, which is this guy. 1 minus p is the probability of the failure, p is the probability of success, and n factorial is n times n minus 1 up to 1, etc. We're going to do Excel here. We'll not use that one. So this example, I'm going to read it. I'm going to take it to Excel. And the easy part in the binomial is we can find the expected value of the binomial distribution easily, and we can find the standard deviation easily. So in the previous example, how to find the expected value, you just multiply n times p, and how to find the standard deviation, you just multiply n times p times q, square root of all of these. So let's go to the previous example. So television ratings, in that game between Seahawks and Patriots, SB Nation reported that the game was the most watched program in history, with over 45% of all people with TV in the States tuned to the game on Sunday. Assume that the 45% rating is correct. What is the probability in a random sample of 20, this is my n, random sample, 2 or fewer would have been tuned to the game? So this is n, which is 20. X is number of people watch the game. Maybe 0, maybe 1, maybe 2, maybe 3, right? What we care about finding the probability of x less than or equal to 2. Right? This is the question. What the probability that we have 2 or fewer watched this game? And what is the p? The p for each trial is 45%. this P is not the same as this P. This is the probability. So if you're confused, you can write the probability PROB. The probability of this, the one that we used to use in chapter 4. This P is the success one. The rate of success for each trial is 45%. So to find the expected value of X, it doesn't depend on X, so it's N times P, which is 20 times 45%, and you get the answer, which is 9. So the expected value, we have 9 people, basically. The standard deviation, which is sigma, is N times P times Q under square root. What is N? 20. What is P? 45%. What is Q? Is 1 minus 45%, which is 55%. All of this under square root. Then you get the answer. So this is the expected value and the standard deviation of the binomial distribution. Again, when we covered the previous part, we talked about this general discrete probability distribution. We have 2 different formulas. Now, when we are sure that we have binomial distribution, we can use shorter way of doing this. We can find the expected value, we can find the standard deviation. So in the next video, I'm going to do the Excel. I'm going to solve this question using Excel functions. The final point that I would like to say here, basically, if P, the probability of success is half, the binomial distribution becomes symmetric, L-shaped. We're going to talk about this later, regardless of the sample size. The skewness, we will have it when n is small and P is getting closer to 0 or 1. The binomial distribution becomes more symmetric when n increases. And these are important comments that we're going to use in chapter 6.